Time to talk about Tor. Now, Tor is an open source, anonymizing and encrypting volunteer-operated proxy network. Tor helps to reduce the risks of both simple and sophisticated network analysis by distributing your internet traffic over several layers or relays on the internet, so no single point can link you to your destination. And that's as you can see here. So this might be you, and you're going over a number of relays before you get to your final destination. When Tor is installed, it places a SOCKS 5 proxy on your client. So if you install it on Windows, you have a SOCKS 5 client on your Windows machine. And when correctly configured, all desired internet traffic can be made to go through that proxy. So you can see here, you would have your proxy on here, and it would force all the traffic to go via this path here. Packets entering the proxy are encrypted and sent into the Tor network, where they are forwarded to another Tor node and another, until finally reaching an exit node where the data is decrypted and sent to its final destination, for example google.com or Facebook. And that full connection would be called a Tor circuit, and there's your exit node there. In addition to this, so that's using the surface web, you can also access what is called hidden services, and these are accessible by these .onion URLs, as you can see here, which is essentially a URL to access the Tor darknet. An exit node in this case isn't required. What you'll do is, instead of coming out of here and exiting to Facebook or wherever it is you're going, you'll go to a server that's within the Tor network, which means your traffic remains encrypted end to end. A key point about Tor is that no individual node or relay ever knows the complete path that a data packet has taken. The client negotiates separate sets of encryption, as you can see illustrated here, or separate sets of encryption keys for each hop along the circuit to ensure that each hop can't trace these connections as they pass through. Tor uses the same circuit for connections that happen within the same 10 minutes or so, and later requests are given a new circuit to keep people from linking your early actions to new ones. So then you might go from here to here, to here, to here, and then out. Let's run through it using the diagrams provided by Tor themselves. So first step, here you are, Alice. You need to know what are the relays. What are the relays that you can connect to? That's the first thing you need. So in order to do that, you need to connect to something called a directory server. And this is the example of a directory server here. You can think of it a little bit like DNS. So you do an encrypted request to this directory server to obtain a list of Tor nodes. Next, Alice's Tor client picks a random path to the destination server. So here we can see the green encrypted lines, and coming out of the exit node to Bob or Facebook or whatever. And this bit here, crucially, is not encrypted. That will be plain text unless you are using an additional layer of encryption, such as HTTPS. Now remember, this is accessing the surface web. This is not accessing the darknet or hidden services. This is just accessing the surface web. And next, and if at a later time the user visits another site, Alice's Tor client selects a second random path again, so we can see a different path. And as we've already said, this can be every 10 minutes or so. Tor cannot solve all anonymity problems. It focuses only on protecting the transport of data. You need to use protocol-specific support software if you don't want the sites you visit to see your identifying information. For example, you can use the Tor browser, which will go through while browsing the web, to withhold some information about your computer's configuration. And we'll go into all that. So think of Tor as simply one element, one tool that enables you to disguise your location. It is just a tool, and it is just one tool. Tor does not provide protection against end-to-end timing attacks. If your attacker can watch the traffic coming in and out of your computer, and also traffic arriving at the chosen destination, you can use statistical analysis to discover that they are part of the same circuit. So Tor is not a panacea for privacy and shouldn't be relied upon as such. With the right methods and tactics, which we'll go through, it can be a very useful tool for aiding in staying anonymous. Another diagram here illustrates the layers of encryption, and this is where the term onion routing comes from. It's layers of encryption, and these layers are peeled back as you go through the Tor network. So the first relay will only see this, and we'll have these encrypted layers within it. The second relay will see this, and the third relay will see this, until finally the actual message is received by the destination host, which is not encrypted, which means that no individual node ever knows the complete path that a data packet has taken. The client is negotiating a separate set of encryption keys for each hop along the circuit to ensure that each hop can't trace these connections as they pass through. Let's go through this again. So your message is encrypted several times, and it's encrypted several times before it even leaves your device. Node A can only decrypt layer A, and when it's done that, it will be able to see the address of the next node, which is here, node B. After the packet reaches the next node, node B, it can only decrypt layer B, which is here, and so on through the layers. For each layer, you use a session key negotiated with the respective node's public key, so only that exact node can decrypt the layer with its session key. When the message reaches the exit node, all the layers have been decrypted and the message is now in plain text, unless an additional layer of encryption is used like SSL. A Diffie-Hellman handshake is used to establish those session keys. Diffie-Hellman allows session key negotiation where even a man in the middle observing the traffic would not be able to determine what the mutually agreed session key was. Tor also utilizes something called perfect forward secrecy, meaning the session keys are ephemeral, as they are only used briefly and then replaced. This then means in the future, if one of the nodes is compromised, previous data that passed through that node cannot be discovered, and private keys cannot be used to decrypt previous data. Tor basically hides your IP address on the network layer and does a reasonable job of it.